Good day, everyone. Today we are going to discuss. You're going to state and prove the theorems in segments formed by chords, secants, and tangent. So we will be learning different theorems here. So let's have first the power up activity. So I want you to study the following figures. How will you determine the measure of each numbered angles? So supposedly we have this figure number 1. We have here a circle and two tangents who meet outside two tangents that meet outside the circle. And it forms angle 1. How do you think will you determine the measure of angle 1? And how about here, figure number 2? A tangent and a secant line meet outside the circle and it forms angle 2. What do you think is the way in determining the measure of angle 2? And we have this figure number 3. Also a tangent line and a secant line meet at a point of tangency on the circle. Meet at the point on the circle. So, and it forms angle 3. How do you think? How will you determine the measure of angle 3? And here we have angle 4. Figure number 4. Two secant lines meet inside the circle and it forms angles, usually angle 4. So how we are going to determine the measure of angle 4? Figure number 5. Two secant lines meet at the exterior point of the circle and it forms angle 5. How we are going to determine the measure of angle 5? Illustrations show the different theorems on segments and angles formed by tangents, chords, and secants of a circle. So let's have first theorem number 1. Okay, we have here two tangents meet outside the circle and it forms angle 1. How are we going to solve for angle 1? In this case, if two tangents meet outside the circle and it form an angle, so in getting the measurement of angle 1, the measure of an angle formed by two tangents of a circle intersecting at a point in the exterior of the circle is 1/2 the difference of the measures of the intersected arcs. Let's see, for instance, we have here angle point A. This is the exterior point of the circle where the two tangents meet. We have point C, point on the circle or the point of tangency, and point B is also the point of tangency, and we have circle D, and we have point on the circle which is E. How to get angle 1? So in getting angle 1, theorem 1 states that it is equal to it is 1/2 the difference of the measures of the intercepted arcs. What are the intercepted arcs here? So we have here the intercepted arcs here, arc BEC and arc BC. Those are the two intercepted arcs. So supposedly we are going to find angle 1 if BEC is equal to 260 degrees. So this big arc here, BEC, is 260 degrees, and we're going to find angle 1. So the formula in getting angle 1 is equal to BEC, which is BEC minus the BC all over 2. Why all over 2? Because it is 1/2 the difference of the measures of the two intercepted arcs. So, since BEC is 260 degrees, what is the measure of BC? We all know that in a whole circle, the degree measure of a whole circle is 360 degrees. So, BC is equal to 100 degrees, because 260 plus 300 plus 100 is equal to 360 that compose the whole circle, right? BCE minus 100, that is equal to 160 divided by 2, that is 80 degrees. So angle 1 is equal to 80 degrees. Let's proceed to theorem number 2. So we have here an illustration where a tangent line and a secant line intersect outside the circle, and it formed angle number 2. So in getting the measurement of angle number 2, it is just also 1/2 the difference of the measures of the intercepted arcs. How do we get the intercepted arcs? So let's see. For instance, we have here point A is the point where the two lines meet outside the circle. Point C is on the circle, point B is on the circle, and point E is on the circle. So we have here, what are the two intercepted arcs? CE, this one here, CE is the arc, and one of the intercepted arcs. Always take first the bigger arc, because if we are going to get the difference between the bigger arc, it must always be the bigger arc first minus the smaller arcs, so the result will always be positive. So CE and CB or BC. So in getting angle number 2, let's suppose we have this one. Find angle 2 if CE is 160 degrees here. Arc CE is 160 degrees and BC is 60 degrees. BC is 60 degrees. Of course, this is not equal to 360 degrees because we still have BE. BE, it's not included. BE is not included because this is not an intercepted arc of angle 2. What are the intercepted arcs of angle 2? We have CE and BC. So, in getting angle 2, the formula is arc CE, the bigger arc, minus the smaller intercepted arc BC divided by 2. So, arc CE is 160 degrees minus arc BC is 60 degrees divided by 2. So 160 minus 60, that is 100, divided by 2 is 50 degrees. So angle 2 here is equal to 50 degrees. Let's proceed to theorem number 3. So we have here a figure. A secant line and a tangent line meet at a point on the circle, and it formed angle 3. So how do we get angle 3? So in this theorem, the measure of angle 3 formed by a secant and a tangent drawn to the point of tangency is 1/2 the measure of each intercepted arc. So what is the intercepted arc of angle 3? So we have here, the intercepted arc of angle 3 is arc ACB. Okay, so how do we get angle 3? So it is just 1/2 of ACB. Supposedly, arc ACB is equal to 150 degrees. So in getting angle 3, so this is ACB equals 150 degrees. So in getting angle 3, it is just 1/2 of ACB. 150 over 2 is equal to 75. So that measure of angle 3 is equal to 75. How about theorem number 4? Theorem number 4, we have here a figure. Two secant lines meet at the point inside the circle, and it formed here angle 4. There are 4 angles here, but let's suppose we have this angle number 4. So how do we get angle number 4? So in getting angle number 4, it's formed by 2 secants of a circle intersecting at a point in the interior of the circle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So supposedly we have these points. We have the interior point intersected by the 2 secant lines. We have point B, and on the points on the circle we have A, C, D, E. So how do we get that? What is the intercepted arc of angle 4? The intercepted arc of angle 4 is arc DE. Okay? DE, which is equal to 120 degrees. Okay? And what is the vertical angle of angle 4? The vertical angle of angle 4 is angle ABC. The one here, the angle B. Okay? So, that is the vertical angle. We get the sum of the two and get the half, that is angle 4. Okay, supposedly we are going to have this one. Find angle 4 if arc DE is equal to 120 degrees. That is the intercepted arc of the angle 4. And arc AC is the intercepted arc of the vertical angle. So, we get the sum of the two because the formula is the sum of the intercepted arc of angle 4, which is DE, and the intercepted arc of the vertical angle, which is AC, divided by 2. So arc ED is equal to arc ED or arc DE is equal to 120 degrees plus arc AC or CA is equal to 100. So 120 plus 100 is equal to 220 divided by 2, so 110. Therefore, angle 4 is equal to 110. Let's have theorem number 5. We have here a figure. Two secant lines meet outside the circle, and it formed angle number 5. So how do we get angle number 5? So theorem number 5 states that the measure of an angle formed, which is angle 5, by 2 secants of a circle intersecting at a point in the exterior of the circle is 1/2 the difference of the measures of the intercepted arcs. What are the intercepted arcs of angle 5? So the bigger intercepted arcs and the smaller intercepted arcs. So we have here, supposedly we are going to find angle 5 if DE, arc DE is the bigger intercepted arc, this one, and the smaller intercepted arc is arc BC, this one. We are going to get the difference between the two and divide it by 2. So this is now the formula in getting angle number 5. So angle 5 is equal to arc DE or ED minus arc BC or CB divided by 2. Since arc DE is equal to 120 degrees minus BC is 50 degrees, so that is 70 degrees divided by 2, that is 35 degrees. How about theorem number 6? We have here a figure. Here, starting in theorem number 6, we are going to get the length of each segment. So from theorems number 1 to 5, we talk about angles. So the answer should be in degrees. So this time, theorem 6 to theorem number 9 will be about length of segments. So we have here a figure where two chords intersect inside the circle. Of course, chords just intersect inside the circle. It never intersects outside the circle. So we have two chords here intersect in the interior point of the circle. And how do we get length or the length of the segment of the chords? So we have here, supposedly, these are the points, chord AC, AE rather, and chord BD. If two chords intersect in the interior of a circle, they intersect at point C. The product means the result of multiplying numbers. The product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chords. See, for instance, here, find BC if line segment AC is equal to 3, line segment CE is equal to 4, and line segment CD is equal to 6. So these are the measurements of each segment. So AE here is equal to 7, right? When you add 3 plus 4, that is equal to 7. But we don't know how long is BD. But CD here is 6. So we're going to find BC. Okay? So in theorem number 6, this is the formula. It is the product of the length. The first chord is BD. BD is divided into 2, so BC and CD. If we're going to multiply BC and CD, that is equal to the other chord segments, which is AC and CE. Since we don't know BC, so we'll just copy BC. CD is 6 equals AC is 3 times this point here means multiplication. CE is 4. So, what is 3 times 4? That is 12. What is BC times 6? That is BC6 or 6 BC. So to get BC, we will divide it by 6. Both sides. So BC here is equal to 2 units. So let's go to theorem number 7. So we have here a figure, two secant lines meet outside the circle. So how do we get the length of each segments? So if two secant segments are drawn to a circle from the same external point, we have here, we have external point A the product of the lengths of one secant segment and its external part is equal to the product of the lengths of the other secant segment and its external part. So we have here, supposedly, the secant segments here are AD and AE. So in theorem number 7, it states that the product of the lengths of one secant segment, which is AD, and its external part. So AD, what is the external part segment of AD? That's AB, means outside the circle, external. So AB is the external part of the secant segment. Secant. It is equal to the product of the other secant segment AE and the external part, which is AC. So the formula is the line segment AD times the external part, which is AB, is equal to the line segment or secant segment AE times the external part AC. Okay, so let's substitute. For example, so we have here AD is 6. Why 6? Because 4 plus 2, that is 6. And AB is 4. Means x, this is x, here is multiplication. X. So equals AE is 8 because 3 plus 5, that is 8. Times the external part, which is 3. So 8 times 3. So 6 times 4, that is 24. And 8 times 3 is 24. Okay? Okay, let's proceed to the second to the last theorem, which is theorem number 8. So in theorem number 8, we have this figure, two lines, or a tangent and a secant line intersect at the point outside the circle. So how do we solve, or how do we get the length of each segment? So if a secant segment and a tangent segment are drawn to a circle from the same external point, the product of the lengths of secant segment and its external part is equal to the square of the length of the tangent segment. Supposedly, we have this one. AC is the tangent segment, and AD is the secant segment. So how do we solve its length of the segments? So the product of the lengths of secant segment AD times its external part, which is AB, is equal to the square of AC, which is the tangent segment. Supposedly, we have here AB is 4, AD is 9. So 4 plus 5, that is 9. BD is 5 and AC is equal to 6. So how do we solve for that? So the formula is AD, the secant segment, times AB, which is the external part, is equal to the square of the tangent segment, which is AC. So just substitute the given formula. AD, which is 9, 4 plus 5, 9, times AB, which is 4, equals AC is 6, then squared. So 9 times 4 is 36, 6 squared is 36. And let's proceed to theorem number 9. In theorem number 9, we have here two tangents meet at the same external point. We have here, if two tangents meet at the external point of a circle, then how do we get each segment? We can say that the segments are equal. So suppose we have here the external point is point A, and first tangent segment is AC and the other segment is AB. So if they meet outside the circle, on the point outside the circle, the two tangent segments are equal. So if AC is equal to 10, AB is equal also to 10. So